Said, we have a special name for numbers that are best expressed like this because, well, for instance, if you look at that first one there, 2 sod 6, you know that 6 is not a perfect square, right?
Yes, sir.
So it's better left like that. Um, so these numbers look this way, and it's better to leave them expressed either the way they are or we'll simplify them. So let me ask, do you have an idea how the left hand side of that number one became the right hand side? Do you have an idea how that might have happened?
Mm. Did they like?
Did they what?
I was thinking maybe they multiplied and then divide, but
Okay, okay, multiply and then divide. Okay, I think I will agree with you on one of that, what you said. I will agree with the multiply part. So, well, technically, maybe you would have, in your mind, you would have done the division before you now express the multiplication. So, let me say what I think you may be thinking. So,
so is it?
yes.
Did they multiply? Okay, maybe multiply the two. I was thinking they square the two and then multiply by 6.
Hmm. Okay. I'm not too sure I understand what you're saying, but let me work on number one. If it looks like anything that you are talking about, you can let me know. Okay, so number one simply says square root of 24, which we can also call sod 24. Okay, so now from our multiplication table, right, there are different things that can give us 24. Um, of course, the very first one is 24 times 1. You know, I always like to start there. 24 times 1 is 24, but that will not help us. Why? Because it's as if we've not even moved from the starting point. We're still at the beginning, which is what? 24. And 24, we all know, is not a perfect square. But the good thing about 24 is that it is a multiple of usually a perfect square and a non-perfect square. Or I don't know if you want how you class the opposite of a perfect square. Okay, so now how would I be thinking? I should be looking for what times what will give me 24, that one of them is a perfect square. So what comes to your mind?
Mm. What times what to give you 24?
And
Uh,
one of them is a perfect square.
4.
4. Okay, 4 times what?
4 times 6.
Excellent. 4 times 6. So I'm sure you can already see the answer coming out. Okay. So now if you remember that this square root sign is actually raised to power half, it helps you to see that indices, the law of indices is just being multiplied. It's just being, implemented here. So square root of 4 is 2, isn't it?
Yes, sir.
So you're left with 2. And then because 6 is not a perfect square, how do we leave it better expressed? We leave it as sort 6. Now, of course, in your calculator, there's nothing wrong with you going to go and find square root of 6. And then, you have let me see, I can guess square root. So I can guess the whole number of square root, but I cannot guess the decimal part. At least because 6 lies between 4 and 9, two perfect squares, 4 and 9. it is not going to be, its square root is going to be more than 2, but less than 9. So that's going to be 2 point something. Now, I don't, we don't, sometimes we don't want to be seeing all those point. So the best thing we just do is what? Leave it expressed like this as 2 times what? Sod 6, just like that. So that's how that left hand side became the right hand side. Okay, so I'm sure you can now tell how the others could have come about. Of course, you can see from 18. 18 is what? A product
Um,
of what and what?
two. It can be 3 and 6 or 2 and 9.
Thank you. 2 and 9. It's 2 and 9 that we want. You know why? Because 9 is a perfect square and 2 is not. Sometimes we may be lucky. Both of them will be perfect squares, but most of the time, it's usually only one that's a perfect square. So yeah, so that's how you now came about 3 sort 2. Look at number 3. Number 3 is 8. Okay, so I'm sure you can see clearly that 8 is what? 4 times what? 2. And by the time you now express the sort further, square root of 4 is what? Is 2, right?
Yes.
Uh-huh. And that's how it came to 2 sort 2. Okay, let's do number 4. Let's do number 4 together. I know sometimes it's fun to do that thing mentally, but at this some other times I think it's better to see it written. It leaves a lasting effect on your mind when you see it written. So square sod 45 is going to be equal to what times what?
5 times 9.
Exactly, 5 times 9. Excellent. So you've gotten a hang of it. 5 times 9, which we know that 9 is a perfect square. So that means it's going to have a perfect square root, if you like, a whole number square root. That's just what a perfect square is. Its square root is a whole number. And of course, since 5, we can't really help 5. We just leave 5 under the square root sign like that. And that's how we came about our trusty um, 3 sort 5. Okay, so um all the others can be solved in a similar manner. Let's look at the next one, which is um the one in green, adding and subtracting surds. Okay, so let's now see. This one is closer to that one that we did together, but even though the other one was like expansion, it wasn't just this, it was expansion. But let's see how this one's look. I'm going to write the left hand side, which is the one in black. I'll start with number 1. Sod 32 plus sod 8. So let's see how that guy plays out. Um, I'll pick on number 1. Sod 32 plus what? Sod 8. Okay. So now the good thing about this one is that the idea or concept that we picked up from the ones that we just saw a few moments ago, we can apply it now. So what do you think 32 we can do with 32?
4 and 9.
4 and
8. Sorry.
8. Okay,
Yeah.
do you see something bigger, something better? Because okay, so now do you know I can work with what you said now? Okay, let me work with what you said. 4 and 8, right?
Yes.
Okay, good. So now the only thing is that, so don't worry. I think this one has two ways of solving it. So this is what I'm going to do. I'm going to solve it the way you just suggested now, the starting point. Then I'll solve it another way. And let's see which one would have gotten us faster to the answer. 4 and 8, right?
Yes.
So let's just write it like that. 4 times 8. Okay. So Let's see. And meanwhile, now, if I'm going with this your method, guess what? I'm not going to touch 8. Do you know why?
Because it doesn't have a square root. You
Okay,
can't.
that's number one reason. Number two reason is because somehow I can see it inside here.
Yes.
So I know that somehow they're going to like tidy themselves up. So this sort 4, we know that square root of 4 is 2, isn't it?
Yes,
So
sir.
we can just do it as 2 sod 8 plus what? Sod 8. And this is the interesting part. So now, I like to see swords as if they were unknowns. Just think about something like this. 2t plus t. What do you think it will give me? 2t plus t
3T.
will give me what?
3T.
Thank you very much. 3t. Excellent. And so that means, of course, you know what I want to do. I'm going to replace my t back with what it was originally, which is 3 sod what? 8. All right, there we go. Um, do you understand what I just did back here?
Yes, sir.
Okay, good. Now, this is what I was trying to say. You see sword 8, sword 8 can still be broken down. So sword 8 can be broken down into what? 4 times 2, a perfect square, a non-perfect square. So that means we're not done yet. Because if they say you should simplify a sword, you have to simplify it in such a way that you won't even see anything that you can break down again at all. You won't see it. So this will give me 4 times 2 down there. Let me put the sword,
Good.
the square root sign over it. So what will happen next?
So I
What do you think
have
will happen
three,
next?
3 root 8. You multiply the
Didn't
4
hear
times,
you. Uh-huh.
which is 8.
Okay, what I should make the square root of the 4, I can leave it as 2, right?
Mm,
Like this. But then the 2 will stay on its own like this. Can you
mm,
see that?
yes.
Now, that's the 2 is staying like that. Why? Because it doesn't have, or not that it doesn't have a square root, though, but a square root is not a perfect square itself. So we just
Yes.
leave it as sort 2. Okay. So what do you see happening outside there? The 3 that was already there will multiply the 2 to give me what?
6.
6. So the final answer will be what? 6 sod 2. Okay. So now this was what I wanted to tell you. Another way we could have done it, right? So let me see if I can do this. I will put an or, a big or on top. Let me draw a line here. So, or, or, sod 4. So 32, right? 32 can also be seen as 16 times 2. Okay, so that's why I was somehow um well, I'll not say I prompted you, Sha. Maybe if I had prompted you further, you would have gotten what I wanted to say. So 32 can be seen as 16 times 2. So let's look at it like that. 16 times 2. But now, contrary to the way we did your own, right? Because I cannot see with this my own method now, I cannot see sod 8 inside there. I'm going to break down sod 8 to also be what? 4 times 2. At least something that I can see, okay, in the other one. Because I know that they will play out nicely when they are like that. So, of course, you know what will happen to 16 times 2. Square root of 16 is 4, right?
Yes, sir.
Okay, so that will now be 4, and 2 will be left as a sword. Just leave it like that because we know that it's not a perfect square. And then on this side, I have sword 4. That's square root of 4 times 2. Okay, so that will be what? 2 sword 2, the one that couldn't be, that is not a perfect square. Okay, so of course, again, this looks to me like what? 4x plus 2x, isn't it?
Yes, sir.
And what would now happen? 4x plus 2x will give me what?
And 6x.
6x. Excellent. 6x. And 6x in this scenario is equal to what? 6 sod 2. If we see x as sod 2. Okay. All right. So did you get it?
Yes, sir.
Okay. So don't worry, I'll send this to you when we're done. All right. So let's move forward. Okay, but you see the interesting thing, we got the same answer. It's just that um it looks like yours took longer, but the important thing is that we got the same answer. So sometimes, I don't know if you've noticed that thing in an exam, something that okay, a particular method that may not come straight to your mind like that. You know, you might find yourself, going another route. But then just as long as you are consistent and you follow through with all the legal math rules that you will surely get to the answer. So it's just that I bet you that if you follow this one on the right hand side, you'll be much faster and arrive at the last question, sooner than someone else. So what's the advantage? Well, if you finish an exam or an assessment earlier than others, you have time to either go through your work, and be more certain that the things that you thought you got correctly are actually correct. You won't. There are some mistakes that you may have made in your bid to get to that last one or to finish the sums that you wouldn't see while you are doing it. Somehow it would slip. But when you come back to look at them, guess what? Somehow you get to see them, you know. But that is on the condition that you have enough time to even go through them. So that's why looking for the fastest methods to get to the answer for any question usually counts. And of course, we should not forget, even though it wasn't like I I meant to be talking about exams, but since we're talking about exams and assessments, we could equally throw in the fact that anytime you come across a number that does not just look like you know it at that point in time, best it's best to just leave it, especially maybe after you've read it once and it's still looking like they wrote the question in French or some other language that you don't know. Just leave it. Somehow, uh, it may make sense later, but it's better to not sabotage the other questions because of a question that you don't know. Okay, so I'm sure you understand what I'm talking about, right?
Yes, sir.
Okay. Okay, so let's move on to another one just for us to get some practice underneath our belts. Sod 8 plus sod 2. Okay, so how do you think we'll go about this one?
So that'll be 2 times 4.
Mm-hmm. Mm-hmm. Okay, I'll go with
Um,
that. I like that suggestion. Okay, but then permit me to do 4 times 2. It doesn't matter, but
Yeah.
I think somehow the way your eye sees things, you know, it kind of clicks. So whether you say 2 times 4 or 4 times 2, it's still the same thing. But I think you'd appreciate it better if you see it this way. And then you'll not be wondering, how did this become this? Okay, so what next?
Mm. And then it will be two.
Yes, the 2 is square root of 4, right?
Yes.
Excellent. So, yeah, go ahead.
Two sort two.
Excellent. 2 sub 2. Next, plus sub 2, right?
Yes, sir.
We can't even help sub 2 because there's nothing it can be broken down into. Okay. All right. So let me see. Oh, this, I'm not saying that you should do this, so, but let's pretend we had to do something with these two. I'm just saying, oh, I'm going to erase this because I mean it's not necessary here. But do you agree with me that you can equally write sort two, right? In terms of, this is like a it's not really necessary, sha. But you can write sort two as you can write sort two like this. Do you agree with me?
Oh, yeah. That's
Yeah, you don't. Look at it carefully.
is
Four
it
times
four
half, is it
times?
not two?
4 times, right? Oh, yes.
It's
Oh, I
two.
thought you
So
meant the on just the half only.
okay, okay, no, 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 no. Everything is under the square root sign. So the only thing now is that this will now introduce, it will introduce, I don't know how to call it. It will look like we're going round, right? Unnecessary steps. But if you need to, now when will that kind of thing play out? If there was half in the other one, which like in this case we don't have. So you might as well just leave it like this. I just thought I should say that, Sha. So because in mathematics sometimes we do weird things just to be able to see if we can get to a particular answer. And it all depends on the question. Sometimes the question might just say express this as, and when you are faced with that kind of question, they're looking for how creative you can get with your solving of a particular question. Okay, so here we go. I always like doing this, even though one might say, I can't, don't you know in your mind that 2 sort 2 is just like, plus sort 2 is just like saying 2 plus 1, 3, and then the answer will now have sort 2. But I like it like this because sometimes it's visually more clearer when you can see, you know, if say, for instance, if somebody might want to do this and not be saying, why did we use X? Well, it's your choice. It's not as if anybody gave you X, but you could have used any other letter you wanted. If X equals sort 2, then you can write that expression like that. So why do we do it like that? Because I think algebra makes it very, very clear what will the answer would be. 3x. And then you can now write it as what? 3 sort 2.
Mm.
Okay. So did you get it?
Yes, sir.
All right. So I think um all the other ones. Okay, so let's do some that have minus in them. Let's go to number 5. We'll do number 5 and number 6 just for practice sake. Hmm. I like that next one. It's just that it's not complete. Don't worry, I'll find questions that have fractions. Okay, so where was I? Okay, number 5 says sod 27 minus sod 12. Okay, sod, excuse me, sod 27 minus what? Sod 12. Okay, so, all right, so what do you think we're going to do with this?
Is that Surd 20? Okay, 27.
Yes, it's 27.
So
Doesn't
is
look like
it
27, Shay.
nine
Let
times?
me,
It's because of the arrow. I didn't see it very well because the arrow was on it.
oh, okay, okay,
Mm.
okay, all
Nine
right.
times three.
9 times 3. Excellent. So 9 times 3. Good thing 9 is a perfect square and 3 cannot be broken down anymore. So 9 times 3 is a good, anyway, it's even the only one. So, I mean, not as if we had other options. Okay, then 12 is what?
Mm. 4 times 3.
Excellent. 4 times 3. And now, even if for any reason you are thinking of considering something else, just look at the 3. They have the 3 in common. So, all right. So, what would that become?
That be 3 sod 3.
Yes, 3 sub 3. Okay. All right. 3 sub 3 minus,
2 sod 3.
good, 2 sub 3. Okay. So, all right. So, now, let's look for a letter. I don't know. I've used C today. Okay. Let's use D. So, if D equals sod 3, right? It's going to look something like this. 3D, oops, 3D minus 2D. Okay, so 3D minus 2D will give you what?
D.
D, thank you. So that will give us D. And of course, D is just as good as what? Sod 3. Okay, so without much ado, let's go to the next one, which is number 4 on our side, but of course, it's not number 4 in that this thing. It's number 6 here. So that's sod 48 minus sod 12. Okay, let's see how that plays out. Sod 48. All right, minus sod 12. So how do you think this one's gonna play out? What do we do first?
Mm. Is it for the 48?
Yes, for the 48.
So I was thinking 12 times 4.
Okay, 12 times 4.
It can't go.
Yeah, it will work, but do you want to try something else that has a bigger? So this is where I'm going. Look for something that has a bigger perfect square and then something that cannot break down anymore. We cannot break down anymore. So, okay, let me even work with what you suggested. 4 times 12, right? If
Yeah.
you if you look at 12, 12 is 4 times 3, isn't it?
Yes.
So this is where I'm going now. If 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 48 is 4 times 12 and 12 itself is 4 times 3, then can we say that 48 is 4 times 4 times 3?
Mm-mm. So, okay.
Can can you see
Can
where I'm going now?
we? Yes.
Uh-huh. So this is what, let me show you. Don't worry. When I write it down, it will become clearer. Sometimes your mind might not be able to pick it, but when you see it written down, you'll be able to pick it. So 4 times 4 times 3. Okay. So this is how it looks. This all this is what? Just 48. Then of course you know how 12 will go. 12, I think we did 12 up there. What did we even do 12 as? 4 times 3, Abi. So we can do that. So can you see how it's going to come out?
Yes.
Uh-huh. Now that 4 times 4 is what?
16.
Is 16, Abi.
Yes.
So if you really look at it very well, right? Um, that will give me 16 times 3. And 16 times 3, 16 itself is a perfect square, whose square root is what? 4, right? So that will help me to, this one I can simplify this right hand side as 2 sort 3 already without having to do it again. Now, sort 16 times 3 is what? 4 sort 3, okay,
Mm.
minus 2 sort 3. Okay, so now I don't know at what point you will get comfortable with not using letters anymore. Maybe your mind will now help you to be doing the letter thing. So you can easily see here that 4 sort 3 minus 2 sort 3 is what? 2 sort 3. Do you agree with that?
Yes, sir.
And that is your final answer. Okay, so let's see what we got there. All right, so um if you want, I can leave this with you. You can, those ones that we did not do, you can just try your hands on them. Let me see if this guy has what I'm looking for. Does it? Let me stretch it a bit. Oops, too small, too tiny. Let me go and look for another one that has more this thing. Uh, we don't have a lot of things here. Okay, this is our official website for TES. I think it's for this thing for teachers, but doesn't really have much of what I need. So let me go for something else. Wait a minute. Okay. I'm looking for something that has, oh, don't worry, let me check here. Might find something. Simplifying sorts. Simplifying sorts that have fractions. Okay. No. Okay. Let me see what is on this guy. Ah, they're looking really, really tiny. Okay, let's see what this guy says. Hmm. Ah, this one like this really give us, and it's from test still. I think I should go for one that's not test. Let's see. No, too simple. Let's see what this one says. Okay. Does this one look? Oh, no, 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 no. No, I'm not looking for stuff like that. Hmm. This one is going is going hyper, very, very hyper things. It's on a hyper level. Okay, let's just look at it. It's with a, can you imagine? Am I supposed to request for it? Okay, all right. So let's see, we can, all right. Okay, so you can still see my screen, right?
Yes, sir.
Excellent. Okay. Um, yes. So this is the question. 4 times sod 2 over sod 5. All that is multiplying a bracket that's containing sod 2 plus sod 8. Okay, so I don't know, maybe I should work it. I think you will appreciate it better if I work it. So you know what we'll do? We're gonna take it uh up here. Should I? Okay, let me just go up. Or do I have space down there? It looks like I have some space. Okay, yeah, let's do it with the space down here. If it's too small, I'll just continue up there. 4 sod 2. I hope I'm copying the right thing. Uh-huh. Okay, over sod 5 times sod 2 plus sod, what is it? 8. Okay, here goes. So how do we take on this? Of course, anything that has brackets, right? Our aim is usually to do what? Take care of the brackets, usually, bottom line principle, expand. Okay. So if we do that, right, what I'm going to do is, please take note that whenever you have something like this, and you know that there's an implied multiplication somewhere here, you already know that, right? There's a
Yes.
multiplication, imaginary multiplication, which, like I say, is an implied one. Then understand that this number, or whatever it is that is in the brackets here, is not multiplying the denominator. Okay, it's multiplying the numerator directly. So this is what I mean. That 4 sod 2 is free to go into the bracket. Now, if you want to allow the sod 5 to go into the bracket, guess what? You have to be putting over sod 5 for the first one. Then separate it with your plus and multiply the top one by the top, and then put your sod 5 at the bottom. The sod 5 doesn't have anything to do with the guys on top yet, at least for now. So you understand what I mean, right?
Yes, sir. Yes, sir.
Oh, okay. All right. Do you have a cough?
No, it's just my throat.
Oh, okay. If you want to take some water, I can give you a few minutes to do that. But
It's fine.
okay. All right. So let's multiply the guys on top. And you can get from your log, um sword means what? Half. Power, something raised to power half. So half plus half is 1, isn't it?
Yes, sir.
So sod A times sod A is A. That's as good as A raised to power 1. So Like once we understand that, then that means that 4 sod 2 times. Okay, so I'll just write it, but then so that you not wonder how the sod disappeared. So should I write dots? Okay, no, let me just put times. 4 sod 2 times sod 2 plus 4 sod 2. Now, sod, okay, no, let's just put the sod 8. So again, so that you not wonder how things disappeared. Okay, so now don't forget that all this is over what? Sod 5. Okay, you understand it so far, right?
Yes, sir.
So sod 2 times sod 2 is going to be 2. So that's going to give us 4 times 2, which on this side is 8 plus, now we can now deal with that, um, what do you call it? The sod 8, which we know is what? Sod 4 times 2. Okay, so sod 4 times 2. So that would leave us with what now? Oops, that line did not go well. Okay, that will leave us with what? Now, I'm sure you can see what's going to happen. Sod 4 in there is 2. That is 2. That 2 will now come and multiply 4. Okay, so let me put a small box around it to show that that's the one I'm talking about. So, of course, that will now be 8 plus, so square root of 4 is 2. 2 times 4, 8. So that's going to be 8. Now, sod 2, right? We now have a friend which is under a sod, isn't it? So sod 2 times sod 2 again will be what? 2. I'm sure you can see what's happening, right?
Yes, sir.
So that will now leave me with 8 plus 16. And 8 plus 16 is what? 20.
Oh,
Is that 24?
yes, sir.
Okay, so that's 24. Okay, and that will be 24 over sod 5. And now there's one rule in surds. You cannot leave a surd in the denominator. So what that means is that I have to multiply both numerator and denominator by sod 5. So that's how you get rid of surds in the denominator. Please take note. Surds can be left in the numerator. That's not a problem. But once you see them in the denominator, always look for a way to eliminate them. So how do you do that? Multiply by whatever is in the denominator. The one that now it's possible that you can have 2 sod 5 in the denominator, but guess what? When you're multiplying, you multiply by sod 5 alone. You don't need to multiply by 2 sod 5. Why? Because the 2 doesn't count. If you multiply by sod 5 alone, it can take out the sod 5. Okay, you don't need the 2 to help with that. So, but it's not, there's no 2 there. I just thought I should say that in case you come by a question like that. So this will now leave me with what? At the bottom, now, sod 5 times sod 5 will give me 5, isn't it?
Yes, sir.
So that will now be 24 sod 5 over 5. Okay. And that's it. Okay. If you really, really want to go further, well, 5 in 24 is what? Some people that want to really go ahead and they don't mind seeing decimal point. 5 times 4 is 20, right?
Yeah, I
Remainder
remember four.
4, remainder 4 over 5. And 4 over 5 is 0.8, isn't it?
Yes, sir.
So 5 in 24 is technically 4.8. So if you really want to, if you really insist, then your final answer is 4.8 sod 5. Okay, so if you look at what they did, um, you see that they stopped at 24 sod 5 over 5. So, like I said, I only pushed it further because some people may, you know, they may say, among the options, there's no one that says 24 sod 5 over 5. But you will see 4.8 times sod 5. So, anyone you see that you know is correct, that matches with it, please feel free to use it. Okay, so did you get that?
Yes, sir.
Okay. All right. Let me check my. So there's a. Okay, we still have. I still have battery power. Let me see how far I can go. 33%. Okay. All right. Let me see. Um. Okay. Okay. So let's see. Hmm. Okay. I like this one. Let's see this guy. Um. Okay. Let's take a look at this. Uh-oh. It's a YouTube video. Oops. Some of these things, I thought it was an image. Okay. All right, no problem. Let's use it like this. Uh, can do the video later, not now. Okay. So let me see if I can pick out the questions. That A is quite interesting because of the two brackets. So yeah, okay, I still have some space here. Okay, so let me write the question out. 2 sod 2 plus 1 over sod 3. Sod 2 plus 1 over sod 3, right? And then if you notice in the bracket, I think they just changed the plus to minus. The second bracket simply changes plus to what? Minus 1 over sod 3. Okay. All right. So let's just be sure I got it. Yes, I did. Okay. So what do we do in a scenario like this? Right? It's expansion. So the rule of expansion still happens whenever you have two brackets, right? And what's that rule? If you remember, you take the first one, you take the first one, you multiply it by the first one here. You take the first one still, you multiply it by the second one here. When you are done, you take the still in the first bracket, the second one in the first bracket, multiply the same order, first And then this second one in the first bracket, you take it and multiply the second one. Okay. You know this principle, right?
Yes, sir.
Okay. So I like to call them principles because you follow them each time you are faced with that scenario. So let's start with step one. Let me number it. This is step one. This is step two. This is step three. And this is step four. Now, anyone you are doing, make sure that you have your signs. You're observing your signs. Plus times minus is minus, minus times minus is plus, etc. Stuff like that. Okay, so step one, sort 2 times sort 2. Sort 2 times sort 2 is what?
Sort 2.
No. Sort 2 times sort 2.
Sort 4.
Sort 4. And sort 4 is what?
2.
Thank you. So it's 2. Just remember, anytime you have sort something times itself, sort something, it's as good as just removing the sort. So that's 2. Okay, so step 2 is sort 2 times 1 over sort 3. That will be, now take note of the sign. That will be minus what? Minus sort 2 over sort 3. All right.
Yeah.
Can you see that?
Yes, sir.
All right. Okay, let's now go to the second one. It has a plus in front of it. So we'll just say 1 times sort 3, that's step 3 now, times sort 2. Same thing is going to be what? Plus sort 2, because sort 2 is on top. So the sort 2 will multiply the 1 over what? Over sort 3. And then finally, careful with this one now. 1 over sort 3 times minus 1 over sort 3 will be, because of the plus times minus, it will give me what? Minus. But now be careful. 1 times 1 is 1. The denominator is sort 3 times sort 3. Following what I said back there, what should be in my denominator after that happens?
What uh, sort
1
3
over sort 3 times 1 over sort 3. What would that be?
times. Okay. Is this sort 3?
No, goodness, goodness. Is there so maybe okay, wait, don't worry. Let me write it again. I'll write it here. I want you to get used to it. That's why I want you to, see it often and often and often. Sod A times sod A. Watch you is as good as A raised to power what? Half. Okay. I want you to see the relationship between surds and indices. Maybe I don't know if that will help you in any way, Sha. And that in surds, when surd in indices, they told us that when two things have the same base, that you can do what? Add their powers. So half plus half is what? 1, isn't it?
Yes, sir.
And because it is 1, guess what? A raised to the power of 1 is what? A. Okay?
Okay.
Okay. All right. So let's move on now. So why I did that was so that you remember that anytime you have sod something times sod that same something, just pretend as if the sod disappeared, went on break, just vanished. Okay. So 1 over sod 3 Of course, even though there is a plus, I've already taken care of the plus and minus relationship. I put my minus there. So 1 over sod 3 times 1 over sod 3 will give you what?
1/3.
Thank you very much. 1 over 3. So, of course, I'm sure you can see what is happening here. This guy and this guy are the same, aren't they?
Yes, sir.
And there's a minus in front of one of them and a plus in front of one of them. That kind of scenario is a canceling out scenario, which means they will subtract themselves out, isn't it?
Yes, sir.
So that means that my final answer is what? 2 minus 1 over 3. Now, at a point I was thinking, are you sure we should not, that thing I did back here where I said 24 over sort 5 times sort 5 over sort 5. I was thinking, are you sure we should not do it before we start working this thing? Then I just remembered, oh, they'll take themselves out, so no need to waste time. Can you see they've taken themselves out?
Yes, sir.
Uh-huh. So 2 minus 1 over 3 is going to give me what? If you want to do, I know you are probably thinking of, well, some people, I don't know if you are if you are thinking about that too, but some people will be thinking about taking the LCM, right? Um, and doing stuff like that. 1 in 3, 3 times 2, 6. 3, that my minus is too big, way too big. Okay, better. All right. Then 3 in 3, 1. 1 times 1, 1. 6 minus 1 is 5 over 3, which will leave me with, um, yeah, which will leave me with 3 in 5. That's 1 whole number, 2 over 3, right?
Yes, sir.
Okay, so I think I want to go with that as the final answer. So you can see it's perfectly possible. In fact, it even occurs more often than not that sodic expressions, when you're simplifying them, the final answer may not even contain a sod. You're simplifying sods, but the final answer will not contain a sod. It's perfectly possible and it's okay if it happens. Okay, there's no law that says that it should not happen. All right, so let me know. Do you have any questions about this one?
Yes, sir.
Okay, all right. So let me see. Do we have, let me see. I'm monitoring my wonderful battery here. Okay, it's 22 now. Okay, so yeah, let's see that B. 98 sod 98 minus sod 50 over sod 32. Okay. Mm, ta-na-na, ta-na-na. Sod 98. They said minus sod 50. Okay. All right. Over what? Sod 32. Okay, so I'm sure you can do this one. So what will we do first? What would we do first?
And sir, 98.
Uh-huh. And it will break it down, right?
Yes, sir.
Into what? What times what? Think about the biggest perfect square you can get from 98 and the smallest imperfect square you can get from 98. In your mind, you can try numbers. You can try dividing by, you can try 2 into 98. You can try 3 into 98. Most likely you find the correct one. early enough.
Mm, 49 times 2.
Eh, Thank you very much. You got it. 49 times 2. So that will give me 49 times 2. Um, okay. Under the first sword. Don't forget there's a minus there. All right. Can you do the same thing for 50? 50 is what times what?
Mm, 25 times 2.
Excellent. 25 times 2. Okay. And what do we have underneath? I'm sure you remember 32 very well. 32 is what times what? If all of them seem to have times 2
Yes.
times 2 in it,
Yeah,
I think
just.
it makes things easier for us. Yeah?
I was thinking 16 times 2.
Yes. That is a very good thought. 16 times 2. And what do we have next? We can now break things down, right? We know that sword 49 is 7. So I'm left with 7 sword 2, right? Um, Sorry. When my mouse wants to act like it's on its own, it writes that way. So 25 is 5. We know that. But 2, we can't help you. Just stay like that. And underneath, um, that my line doesn't look too good. Okay, much better. Sword 16 is 4, and that is 4 sword 2, Abby. So, what is the next thing we have? So, can you tell me what do we have next?
Mm, wait.
So, by this time, right, start
Mm,
imagining that. Okay, so let me make it simpler for you. By this time, you can do something like this. Let's, I don't know what letter you have in mind. Maybe I should use
X.
Q.
Okay.
X. Okay, okay, let's do X. Everybody loves X. Okay, let X be equal to what? So 2, right?
Yes.
So we'll see how it all plays out. So this will leave me with 7x minus 5x over 4x. Okay, so 7x minus 5x is what?
So, and that's 2x.
That's 2x. Thank you. So that's 2x. And 2x over 4x is what?
X over 4x. Oh, that's 2x.
Over 4x.
2x.
So the x will cancel itself, isn't it?
Yes. Oh, does the S?
Uh-huh.
Okay.
Leaving me with what?
2.
1 over what? 2.
Mm,
So can you see what happens? At the end of the day, my answer is what? Half. See that?
yes.
Okay. It looks like these guys have decided to be good. I'm sure you'd have noticed my screen lit up a bit back there. Let me see if I can quickly use mine. But don't worry, it doesn't mean that we're going to. Let me see what I have here. So, as I was saying, it doesn't mean that we're going to do another 1 hour. I'm just glad that at least the laptop can be charging while we're working. Okay.
All right, so let's do the last one for today, and that would be 2 sub 2 minus sub 3 over sub 2 plus sub 3. And this one I have to go all the way up there. So I'm going to draw a line, separate them, so they don't get mixed up. Okay, let me see how far I can take that line. Okay, I may not even exhaust the line. Pretty sure I won't. Okay. Let me just stretch it in case I have to repeat this. If I have to, okay, let's put it. Okay, I think I can stop here. Okay, all right. So, what was the question again? Sir? Two sub two, 2 sub 2 minus sub 3 divided by sub 2 plus sub 3. So how do you do this one now? Do you see the difference between this question and the one that we did before it? Can you see the difference?
Yes, sir.
Now, whenever you have this kind of scenario, you have technically you have a sodic expression in the denominator, not just a single sod. You know those other ones who are just having either you have sod 32 in the denominator or like the one way before it, maybe two that we did before it that had something like sod 5. So those ones are just I don't know how to call them, just single sod. But when you now have something like this, something plus something in the denominator, how do you handle it? So now I'm going to introduce something else which we've not done today at all. And that is what is called conjugate. Okay, so the conjugate of a sod, a sodic expression, is simply the same sod, but instead of a plus in between, there's a minus in between. Okay. Now take note. There's something I didn't mention it when I was doing it, but you see this place. Let me point you to the place so that you remember it. This place here where we were doing this, where is that place where we had sort five? This place, everything that we are doing here, where I said we don't want to see salt in the denominator, it has a name. I'm going to type the name here so for reference. It's called rationalization. Okay, so that's a big name, a big word for something so simple, which is what? Just get rid of the sword. That's just what it means technically. You don't want to the sword in the denominator. So rationalization for a simple sodic um, ratio like this is a fraction is what? Multiply by whatever is in the denominator. That is a sword. I told you that if you have something like 2 sword 5, ignore the 2. Just multiply by sword 5. The 2 will take care of itself. Okay. The two will eventually become 2 times 5 and that will give you 10. But in this case now, you can't do that kind of thing. You can't even think of it. Okay. So what do? You multiply the numerator and the denominator by what is called the conjugate. So what is the conjugate? How does it look? I told you the conjugate is simply the same sword. Oh. So what do I mean by the same? Sword 2 plus sword 3. how it's going to look. Sort 2, sort 3. But instead of plus, the opposite of plus is what? Minus. Always aim for the opposite. Okay. Always aim for what? The opposite. And whatever you do to the denominator, make sure you do the same to the numerator. So I'm sure that will ring a bell when you see it. Okay. So
Yes, sir.
all right. So here we go. Now, don't go and make mistake and say this cancels this. No, the whole aim of you bringing them into the picture is so that they can make a change in your expression. Now, why did we come to this? I don't know if you remember difference of two squares. Do you remember difference of two squares? Where we said that when you have something like this, x squared minus y squared, that x squared minus y squared is equal to um, not less than I wanted to know, is equal to x minus y, x plus y. Do you remember that um, factorization principle? Difference of two things. I think we touched on it a bit that time when we were looking at factorization.
Yes, sir.
Okay, so this is the principle that even made conjugate of surds necessary. So you can see this looks like my x, the surd 2 looks like my x, and the surd 3 looks like my y. So if you look at in one of the brackets, there's a minus. In the second one, there's a what? A plus. But the things on the side of the plus and the minus are exactly the same. So what should you just simply do? Square both of them, but make sure you keep the one on the left hand side on the left, and make sure you keep the one on the right hand side on the right. Don't mix it up at all. So if we do that, we follow that rule, see what's going to happen. I'm going to take on the numerator next, but just be patient. You will see how everything will come out so that we don't confuse anything. 2 sub 2 minus sub 3. So I'm now going to be putting these guys in brackets so that they are getting ready to work on themselves. Times sub 2. The numerator looks as if nothing has happened, but don't worry, we'll soon see action there. Okay. Then the denominator is the one where things seem to have happened. So just take everything from the right hand side and move it to what? Transport it to the left, which is this. Okay? Just transport it
Yes,
like
sir.
that, exactly like that. So now guess what? So 2 squares is what?
Oh,
Hmm.
what did you
Do you
say?
agree with that? So 2
Oh, so it's two
is
square,
as good as
two.
so 2 squares is as good as so 2 times so 2. Do you agree with that?
Yeah.
Aha. So I'm sure something should have clicked in your mind now. So 2 square will give you
Will give
what?
you what? Mm, two.
2, exactly. Just 2. Nothing else. So that's the beauty of it. Salt will just vanish. 2. Alright, so now we already know what the denominator is. 2 minus 3, isn't it?
Yes,
So
sir.
for your own sake, I'm going to write it, but I already know what it should be, which is minus 1. But let's just write it so that it doesn't look like it's vanishing 15. All right, so now the guys on top is my focus now, and it's an expansion thing. So we're going to treat it literally the way it is. So I'm going to start with 2 sort 2. 2 sort 2, of course, you know what we'll do now. Times sort 2. What would that give you?
What did you say? Sorry.
2 sort 2 times sort 2.
That would be four.
Remember, sort 2 times sort 2 is 2 already, isn't it?
Yes.
So 2 times 2 will give you 4, right?
Yeah.
Okay. So we have 4. Now, you're not done. Oh. You will now take 2 sort 2 and multiply it by sort 3. Now, sort 2 times sort 3 is sort 6. Am I right?
Yes, sir.
So don't forget the 2 in front. So it will now become 2 sort 6. Don't worry. Things might play out. So let's see how it's going to happen. Now we're done with the first one. We now take on the second one. Sort 3 times sort 2 is sort 6, right?
Yes, sir.
Okay. And then finally, sort 3 times sort 3 is what? Don't forget the minus. So minus sort 3 times minus sort 3 is what?
Plus
Plus,
nine.
isn't it?
Yes.
Uh-huh. What? I didn't hear you. What did you say it will become? Plus what?
Nine. Wait, what did you say? What did you ask?
Sort 3 times sort 3.
That's nine.
Sort 9, which is simple. Hmm? So, okay. Anyway, don't worry. I know you will get it. You will. Sort 3 times sort 3. Sort of a number times that same sort of that same number. It's simply the number without the sort. Okay. So, can you see what's happening in the middle?
Yes.
Minus 2 sort 6 minus sort 2. What do you think that will give you?
Mm,
If you think about the sort 6 as x, just imagine that that sort 6 is x. So that's going to be like 2x minus 2x minus x, isn't it? Is that not minus 3x?
yes, sir.
Uh-huh. So that's going to leave me with 4 minus 3 sort 6, okay, plus what? Plus 3. I want you to see something that the important thing is that in all our simplification, there's no sword in the denominator anymore. Did you notice that?
Yes, sir.
Which is the original thing we did from the beginning by introducing the conjugate. Okay. Remember this thing I told you, it's called the conjugate. So sort 2 minus sort 3 is the conjugate of sort 2 plus sort 3. Okay, so can you leave the answer like this? Well, not really, because we still have some common like terms, which is 4 and plus 3. And you don't have the minus 1 at the bottom there. So 4 plus 3 is what? 7. You can
Mm,
write it like this. 7 minus 3 plus 6. You can't break down 6, so you just have to leave it like that. But now what can we do to this minus 1? So you can do this, when you divide something by minus 1, um, what can we do? Okay, let me do it like this. Can we can do the minus 1 like this if you agree with me, right?
mm,
So do you understand what I did back there? It's as if I just did the expansion. Minus 1, I divided the 7 by minus 1. I divided the minus 3 sort 6 by minus 1. It's still there. Oh. The minus is still in between them. But I allowed the minus 1 to be separated across two of them. Just like I would have done if I was doing a multiplication. You get?
yes, sir.
Okay. So that 7 over -1 will become -7. And then the -3 × 6 divided by -1, the minus minus will become plus. So that will now put 3 × 6 in front because it's the plus, the positive one minus what? 7. And this is your final. This is how you are looking at it in, maybe among the options. This is how it should look. 3 × 6 -7. Okay. I know that we've done a lot today, but I promise you, if you go through this again, it will stick. The one I want you to remember very well because it will make you fast is that um, when a sword multiplies itself, sword 2 times sword 2, what happens? The 2, it will just leave you with 2. Okay? Sword x times sword x is x. But take note, I didn't say that x times sword x is x. There has to be sword on two of them. Okay. So sword 2 times sword 2 is 2. Okay.
Okay.
Okay. So I'll stop here. Do you have any questions? I hope you usually go through these things I sent to you.
Yes, sir.
Um, okay. So I think, okay, let me just put it here for conjugate. Um, conjugate of a sword is used to rationalize um, expression. Okay, let me just call it an expression. Expressions that have third, um, third, uh, no, no, let me call it what it is. So fractions, right, that have third, third, third expression, third expression, and in that I'll say everything have plus, um, um, plus, I want to say, or minus. Okay, all right. And the conjugate is usually the same thing but opposite. So, for instance, conjugate of okay, this one I think this one has finished this job. Conjugate of, for instance, 1 plus 3, 1 plus 2 plus 3 is 1 minus 2 plus 3. Okay, so say minus. If you say minus in between, you put a plus. That's just the law. Okay. All right. So you're good, right?
Yes, sir.
Sorry if I've overloaded you today and you're on mid-term break and feel like, are we in school again? So just a way of keeping your brain sharp. Um, so yeah, I'll send this aside from it and we can That's it. Okay. If you don't have any question, um, have a good rest of your evening, and yeah, we'll see again on Thursday.
Okay, sir. Thank you, sir.